Good morning, good afternoon, good evening. My name is Peter Buckley. I'm head of sales with Cambridge Technology. And once again, welcome to our webinar that we're presenting jointly with Confluent on establishing a streaming platform, a hybrid cloud strategy, and focusing on the Amazon Web Services platform. Your presenters today are Padmanabha Debnath, who we affectionately know as Deb, from Cambridge Technology. He's our Director of Technology, and Patrick Julie, the systems engineer at Confluent. They'll take you through the technical side of this presentation. A couple of quick housekeeping notes. There will be a Q&A available at the end of the presentation. We're going to try to keep this to about 35-40 minutes. And once that's complete, we'll go through some questions. We will make this available to you as a recorded webinar afterwards if you want to spread it around your organization. And once again, we thank you for coming. So the agenda will cover what is event streaming, introducing Apache Kafka, what is the Confluent Platform, what is Confluent Cloud, hybrid and multi-cloud strategies, and if we have time, we'll get into a case study. Just a little bit about Cambridge to kick us off, and I'll give you a little information about Confluent as well. We've been around since 1999, about 450 employees globally, and we have locations in the US, Germany, and India. Our consulting services include application development, big data services, BI, BA, data lakes, data warehouses. That leads into AI, machine learning, IoT, cloud strategy, migration and management, enterprise mobility, infrastructure management services, and DevOps. We hold the certifications noted there, CMI Service Level 5, ISO 27001 and 20001. We're an AWS APN Advanced Tier partner, and we're a Confluent Focus partner for the Southeast. We engage with technology partners. As you can see, we work with all the major cloud providers, Amazon, Azure, GCP, and Oracle. Data streaming, Confluent is our partner with mobility and low-code OutSystems. Application performance management and identity access management, New Relic and ForTruck CA. Testing at Pika, Oracle, and data analytics, Tableau and IBM Watson. Confluent was founded in 2014, and importantly by the creators of Apache Kafka, based on technology developed while at LinkedIn. And they're the largest contributor of Apache Kafka out there today. Over 1/3 of all Fortune 500 companies are using Kafka in production, and 60% of companies process 1 million plus messages daily through Kafka. It's a very powerful platform, and we're very pleased to be a partner with Confluent, and even more pleased that they're taking part in this webinar with us today. So at this point in time, I'm going to turn this over to Deb, and he will hand off to Patrick at the right point. I'll come back and see you guys at the end of the webinar and go through the Q&A. Thanks again for attending, and Deb, it's all yours.
Thank you, Peter. Good morning, good afternoon, everybody. Thank you for joining the webinar today. I'm going to start off with speaking a bit about what exactly is event streaming. Moving on, we know there are two models of data integration, or ETL. One is the ETL Hadoop-based integration model, which is great because it's highly durable, persistent. We get the data in an ordered form, and it's highly scalable. But this doesn't work because it's batch-based, it's expensive, and it's time-consuming. Typically, we get reports or analysis of data at the end of business or the next day after 24 hours. But is there an end of business or end of day for several businesses? No. For several businesses, it's 24/7. For something like the banking industry, there's no point knowing about the credit card fraud alert the next day. I need to know about it right now in real time. So the other paradigm, which is the messaging-based approach, that is meant to deliver data in real time to applications. The advantage of this model is it's real time. However, now this model has several drawbacks. It's not scalable like a Hadoop HDFS based system, which we saw in the first model. There is no persistence in queuing based system or in PubSub based messaging systems. The messages are gone. There is no persistence. There is no way to go back and replay and see with a different piece application code what would have happened with the same data. There is no, if something goes wrong, there is no history to replay and fix it. So the situation which most businesses are in is if you want to do ETL or HDFS Hadoop based integration in real time, you cannot do it. And if you want to do messaging in a way which is highly scalable, which is persistent, durable, and with replay, you cannot do it. This is the problem which event streaming attacks and combines. Moving on, as we see, it combines both the approaches, the pros of both approaches, and allows for processing data as a continuous stream of events as they happen. The HDFS-based system was only used for batch processing, whereas the messaging-based kind of architecture is more real-time driven. But when we speak about event streaming, we are actually processing a huge ingress of high volume of data in real time, and that's why it's very key to several businesses. Moving on, here are a few examples which applies. It pretty much event streaming applies in most industries. If we look at the auto transport industry, without event streaming, what would we do? We would need to call and check for the driver's availability. There would be no knowledge for the driver arrival. But look at what we can do with event streaming. There's the real-time driver-rider match, the real-time diagnostics, ETA. Just the way I was talking about banking, there's no point doing nightly fraud checks and updates. These things need to happen in real time. Similarly, in retail, out-of-stock email. Versus the real-time inventory or real-time recommendation, sales report. That's where the beauty and the power of event streaming comes in. Now, moving on, I'd like to introduce Apache Kafka. So what exactly is Apache Kafka? It is a messaging system, a storage system, and a streaming platform, all the three combined into one. If we look at the earlier two approach, we saw the HDFS approach, which is batch-based, which is great for historical data. But I can't do anything about real-time events. And the other approach is for messaging-based, where I would be processing data in future, whatever comes in. But how do I combine both of this into one platform? That's where Apache Kafka comes in, where it combines the advantages of the beauty of both the systems into one. It's a messaging system, it's a storage system where it's durable, highly scalable, with ordered, and I can go back and replay the stream as it occurs. And stream processing. I need to process stream of data or events in real time as they happen. Kafka runs basically started at LinkedIn. It's now an open source Apache project with a broad deployment. It runs as a cluster which stores streams of records in topics. And topic is nothing but a collection of categories where producers send data to. Topic is maintained in a distributed partition log. The concept of partitioning is breaking the data into chunks across servers. And publishers even have the option to choose which partition to send the data to. Essentially, in its heart, Kafka is composed of 4 APIs. producer or dealing systems or APIs applications dealing with producing or publishing records or messages to the broker. We have the consumer API, which is nothing but systems which deal with consuming data or from the Kafka broker. We have connector API, which are nothing but they are reusable producer and consumers connect to different systems. We could have connectors we could have a JDBC connector, which can connect to Oracle, MySQL, MS SQL, any of this relational database. We could have a S3 connector for AWS S3 bucket. We could have a Salesforce connector. We could have Oracle connector. We could have Elasticsearch connector, Hadoop connector. There could be anybody could contribute and build a reusable producer or a consumer to connect to source and different sync systems, bring them together with the connector API. And streaming API is nothing but which is used for building, which is used for doing stream processing. That's where in traditional approach, where I process historical data, I can only process data till the last record, but I cannot move forward. And for the messaging-based systems, I only process data which comes in the future. But what about the historical data or data in the past? So now with streaming API, basically a streaming application can start processing huge volumes of historical data, and it can continue to process data or stream of events as they occur in the future. So basically, one application, a streaming data pipeline or a streaming application, can handle huge volumes of historical data and can continue to process data in the future. That's where the beauty of Kafka comes in. Moving on, the motivation for Apache Kafka, I've already spoken about it. The two traditional approach, and what happens as you add more and more source systems and sync systems or different types of data integration or different systems come into the organization or the enterprise, it eventually becomes a spaghetti of custom written, managed and maintained ETL code, which becomes more and more unmanageable and unmaintainable as we move forward. So that's one of the main motivating factors for creating Kafka. Moving on to the Kafka architecture, we already spoke about this. I'm not going to spend a lot of time. We have input systems, we have producers which produce data and send them to topics. We have a set of Kafka brokers in the center. We have Zookeeper, which manages the core dependency. We have consuming applications or consumers who are consuming data from the brokers and sending them to output systems. These could be anything, databases, ML models, dashboards, BI dashboards, any kind of analytical tools or things which the organization is using. Moving on, the power of Kafka. Apache Kafka is the de facto standard today for real-time streaming. Basically, there's no alternative to Apache Kafka. If you really want to do real-time streaming, you've got to be using Apache Kafka. It's reliable, it's done in real time, it's scalable, it's persistent, and just a bit of information on the right side, as we can see, 2 trillion messages a day is being transferred, processed at LinkedIn every day, 500 billion events a day, 1.2 petabyte. At this point, I would like to hand it over to Patrick to introduce the Confluent Platform and Confluent Cloud. Over to you, Patrick.
Thanks, Deb. Hi, everyone. This is Patrick Drewley from Confluent. You can go to the next slide. What I want to talk to you about is understanding what we mean when we say Confluent Platform. And to do that, we kind of have to look at the two ways that we deploy our platform. So it comes in two flavors. One is a self-managed software that you can pretty much run anywhere, private data center, public cloud, in Docker and Kubernetes and all that good stuff. And then we have our fully managed cloud service, which runs on the leading public cloud vendors and it's really the Kafka as a service, true fully managed service model for those that are in the cloud. If you go to the next slide, we can see really what makes up the platform. So as Deb was talking, Apache Kafka is the core of our platform. It's what we really founded our platform on, and really what we've done with our ecosystem is try and build out higher levels for different types of adoption. So when we look at kind of our middle tier of tools and toolbox, they're really about adoption, developer enablement, and making Kafka easier to use and providing a broader user base to the ecosystem. And then at the top of that platform is really our enterprise features, which are geared at making Kafka and the Confluent Platform fit into your enterprise, which is full of all sorts of policies and processes and requirements to meet the needs of a large-scale organization. Let's go to the next slide. And in that enterprise tier, we have a couple of different tools. So one is Confluent Control Center, which is our web-based management portal and monitoring portal. It allows for really visibility into the entire platform, so it can look at your Connect environment, streams monitoring, broker information, throughput, all that good stuff can all be found in Confluent Control Center. We also have Confluent Replicator, which is really designed to move messages between Kafka clusters. So it provides both, it provides a couple of different use cases. So it provides both use cases related to high availability and disaster recovery, but it can also provide use cases for data aggregation and basically intercluster networking, so that you have the ability to move messages between clusters that may be in completely isolated data centers. And then we also have Auto Data Balancer. Oh, sorry, go back one. We also have Auto Data Balancer, which is really about maintaining the cluster, keeping the workloads balanced. And then we have some additional security plugins, role-based access control, and then, of course, our world-class enterprise support for the entire platform. Okay, next slide. So without Confluent and really without Kafka, you're kind of in this state where you have these different lines of business, a lot of point-to-point integration, a lot of applications, a lot of databases, potentially some microservices, other SaaS vendors and environments. And the goal, really the problem statement for Confluent is to bring, if we look at the next image, is to bring event streaming and Kafka to the heart of every business, and really make it the central nervous system of your organization and of your data. If you can go to the next image to kind of show what that looks like. And at the bottom of this, we kind of have this universal event pipeline. So this is kind of all the things you need to do to kind of get your legacy systems plugged into this event streaming paradigm. And then above that, kind of the utopia or the higher level goal is to start building these contextual event-driven applications. And that's where the machine learning, the real-time customer 360, real-time inventory, real-time, data transformations and ETL come into play. And that's where you can really grow not only the application usage, but the way that you handle and deal with messages in your organization. Next slide. So I mentioned Confluent Cloud as one of our deployment models, and to get a sense, I mean, if you look at, if you want to understand what it is, it really still is our platform, right? It still is Kafka. It still is providing a lot of the same APIs that you're used to when you're talking about Kafka, but it is really Apache Kafka re-engineered for the cloud. So a lot of the features that come with having cloud infrastructure, like multiple data centers or availability zones, multiple regions, commodity hardware in the sense of having detachable and reattachable disk volumes. All of that is being leveraged by Confluent Cloud to make this a fully managed service. If you look at the next slide, there are two flavors again to Confluent Cloud. One is our enterprise cloud, which is really built for mission critical applications, large scale enterprise deployments, and comes with 24/7 gold support, a 99.5% uptime guarantee. We can do pretty much any scale that you can imagine, both small scale, one message a day to 1 million messages a second. And we can provide multi-zone availability and really spread the cluster out across availability zones within an AWS region, so that if an AZ goes down, you still have a running environment performing at expectations. And specifically in AWS, we can do VPC peering for connectivity, and we can also do transit gateway for those familiar with that, which allows for private networking between your client application environments and Confluent Cloud. Alternatively, let me go back one second. Alternatively, we do have Confluent Cloud Standard, which is really about enabling a broader developer community, and it actually has some limitations to it, but is really designed for that developer tier environments and for smaller organizations. Go ahead. So all of this, when it comes to cloud, is really about agility. So you get scalability, from 0 to 100 megabytes per second. We do all of the sizing in terms of the number of brokers, so that's something you really never have to worry about. It's got a consumption-based model, so you really only pay for what you're actually sending and receiving from Confluent Cloud. And it is a fully managed service that includes schema registry, KSQL, and for AWS specifically, an S3 sync connector, which would allow you to read off of topics and send those messages to S3 buckets. Now, Confluent Cloud Enterprise, as I mentioned, adds some additional features to that set, including having multiple availability zones, and this 99.95% uptime guarantee is something that we actually have in writing and available to our subscription customers. And it's specifically a dedicated VPC for your cluster when you're using Confluent Cloud Enterprise. And that gives a lot of people, security, meets a lot of security requirements in some cases, and gives a lot of people confidence in terms of isolation from other customers. And I'll swing it back to Deb to talk about some of the hybrid cloud strategies.
Thanks, Patrick. Moving on, we will look at how Confluent Cloud can address the needs of an enterprise to have a hybrid cloud model, being able to use the power of Apache Kafka and the Confluent Platform on-premise as well as on the AWS cloud. We can run mission-critical enterprise apps with guaranteed uptime, like 10.95, as Patrick was mentioning earlier. We can do more with Apache Kafka, but the best part is the replicator component from Confluent, which allows us to transfer or replicate data across two Kafka brokers in different geographies. I could be replicating I could be basically setting up my DR on AWS, replicating my data on real time from my data center. And eventually, I might want to move to the cloud, move everything to the cloud. I could have multi-cloud strategy. I could be replicating between GCP and AWS. So streaming across hybrid and multi-clouds, the bridge from on-prem to cloud with hybrid Kafka. And that's where, moving on, what I was talking about, where we could have a private cloud and the public cloud on the other side, and the bridge or the hybrid cloud in between, which is fulfilled by this product or this component from the Confluent Platform, which is called Replicator. This is quite similar. People who have used Kafka and Mirror Maker, the Replicator is Mirror Maker and more. It not only replicates the data, it replicates the metadata also across two Kafka brokers or clusters, which are geographically apart. And this is a great tool or a great way in which I could have a streaming platform and fulfill my hybrid or multi-cloud strategies. The next slide, where we're trying to show a bridge to the cloud, AWS cloud with Confluent Replicator, where if we see on the left, where I do not have a streaming platform, I have everything going everywhere. It's again a spaghetti. Versus when we have Kafka as the streaming platform, the streaming data, which is the source or my core or my primary cluster is in my data center, and I could be replicating the entire data in real time to my DR or to another data center on the AWS platform. Moving on to a case study. So the client is Iron Mountain Corporation, which develops digital and physical information management software solutions. The company also provides document information management solutions, information governance solutions, these kind of products. The challenges which Iron Mountain maintains or has is that they have an extensive portfolio of IT applications critical to the success of the business, and to support their growing needs of seamless application integration and increasing velocity of data, variety of data, and new services which are being added. They need to have a platform called the Global Enablement Layer, which they call GEL. And one of the core components of the GEL platform is to have a streaming platform or integrated or message bus, or a message bus which is really enhanced for a high-ingress data store. So this is what was the solution we had provided for them with the Confluent Enterprise offering, where the technologies which we've used is the entire, most of the components from the Confluent Enterprise platform, the REST proxy, schema registry, KSQL. We have connectors for Oracle, for Microsoft SQL, RabbitMQ, and a SQL Server. If we move on to the next slide, we'll get a better picture of what is happening, or rather what was happening earlier is these different systems which we see on the left, scanning servers, FTP servers. These were sending all kinds of events when files are created, updated, and all these events were being handled by Sonic ESP. And the goal of our client was to move all different kinds of integration systems and move to one consolidated platform, which will be driven by Kafka and Confluent. So what happens is, in this model, we have the data which has been generated being sent to a local collector, which again routes these XML data to converts it to JSON and sends it via the different connectors, which I was talking about. We are using connectors for SQL Server, for Oracle, which is pushing the data into a specific table that triggers a stored procedure, which creates these analytical reports which they see on the dashboard. So this is how the client derives real-time, gets to have a real-time streaming platform, which is highly scalable, durable, persistent, and ordered, where I can replay the events. And the client gets business agility with this move to an event-driven aspect. Thank you, everyone. Over to you, Peter.
Thanks, Deb and Patrick. Hopefully that gave you folks a lot of information. We have a couple of questions that we can go through here. We do understand that your time is precious, so we want to keep this as concise as possible. But I think these are mostly going to be directed to you, Patrick. But first one is, how is Confluent Cloud sized?
There we go. So, sorry, I just had to be unmuted. So Confluent Cloud is sized by throughput and retention, or average retention. So it depends how much data you're going to send to Confluent Cloud, how long you want to retain that data, and then also how many times you're going to read that data. So that sometimes we call that, you can think of it as fan out or the read throughput. And those are the main variables that go into the sizing for Confluent Cloud.
Thanks, Patrick. Next question. What happens if an AWS region goes down, and have you experienced any issues around AWS?
What happens when well, lots of bad things happen when an AWS region goes down, but there at this point, for specifically for Confluent Cloud, we don't currently have automation to provide failover across regions. So there obviously would be a service disruption until you had the service running in another region. There are ways to help prevent that. One would be to use Replicator, as was discussed during the webinar, to copy your data to another Confluent Cloud instance in a different region.
Have you had any issues with Amazon to date?
I am not aware. Yeah, I'm not aware of any region level outages to date. I don't have the full history, but I'm not aware of any.
Yeah, I'm not aware of any in the real recent past. So as everybody should know, Amazon's a very mature, secure, and stable platform. Let's see, next question. How does client security work with Confluent Cloud?
It's really a fairly straightforward security model using an API key and secret for authentication. And all of our endpoints are SSL, TLS encrypted. And that kind of provides both the authentication and encryption. And then we can also layer on access control lists for authorization at the topic level to assign to different application service accounts to decide whether they can read or write from particular topics.
Thanks. Let's see, a couple more. How does Confluent Cloud compare to MSK?
Well, they are both kind of Kafka in the cloud solutions. That is something they have in common. But really, it starts getting different from there. I think Confluent Cloud is really designed as an enterprise-grade, fully managed service. And for the most part, MSK right now is really about just hosting and some provisioning that is done for you from a software perspective. Confluent Cloud is really looking at the full life cycle of your journey with Kafka from day 1 to day 365.
Great, thanks. And let's see, the final question. Can I choose which topics to replicate with Confluent Replicator?
Yes, you can. You absolutely can. You can choose based on a whitelist of topics that you want to replicate between environments. You can also actually establish like a regular expression to pick and choose topics that way, assuming you use a fairly standard topic naming convention.
Great, thanks, Patrick. And once again, thanks, Patrick, for joining us, and Deb, for your part of the presentation. We really appreciate it. Mostly, we want to thank everybody who came to the webinar. We hope that it was topical and that you gained some information that was insightful and helpful. We did try to keep it around 40 minutes so that we pay attention and respect your time. We will continue to do additional webinars, both as Cambridge Technology and with Confluent. If there's anything we can help you with, we'd love to do that. Just contact us any place you can there in the thank you slide that's available. We'll also send you a link to this recorded webinar so that you can view it again if you'd like to, or review a specific part, or pass it along to people within your organization. Again, thanks so much for joining. Hope to see you again at our next webinar. Have a great day.